So welcome again to Historical Society History Talks at the Old Staples Academy. If you are interested in some of the events here, please sign up for their newsletter. They have some posted on the bulletin board there. And we're just so grateful to the Congregational Church and the Staples Academy Foundation for letting the Historical Society host talks here. And this time it's in partnership with the Easton Cemetery Committee. We're very grateful to Dr. David Leslie for taking time to come here tonight and explain his use of the latest technologies and his analysis of the Den Cemetery site. I leave it to you. Thank you so much for being here.
Sure. So can you hear me? I don't know if this How about now? Yeah. Okay. So I'll stand over here. Is this dark enough for everybody to see the screen?
Yeah. Yes.
Okay. So yeah, I'm going to talk today about the geophysical survey that my company, TerraSearch Geophysical, did for the town of Easton at the Den Cemetery. And here we can see a picture that we took after members of the cemetery committee helped really clean up and sort of beautify some of this so that we could do the survey. So all the leaves and the trees, the down deadwood has been removed. This is, just keep in your mind, this is what the cemetery looked like when we did the survey. I'll just give you an overview of where we're going to go during this talk. So we'll do a little bit of the historical background of the cemetery. I am by no means an expert on the historical background of this cemetery. So I'll be presenting a lot of other people's work. We'll then talk about the Den Cemetery itself. I'll go over some of the remote sensing techniques that archaeologists use to identify marked and unmarked burials. We used a number of different techniques during this survey. So I'll talk a lot about ground penetrating radar, but we also use unmanned aerial vehicles, so drones, to do a lot of imaging of the cemetery. We also did some other, just sort of walking around and noticing things that are important to understanding where unmarked burials are, depressions in the ground, that type of work. And then we'll talk about the results of the survey itself. So the survey of the cemetery, how we did it, and the survey results. So the Den Cemetery is sometimes referred to as the Little Egypt Cemetery or the Wheeler-Baldwin Cemetery. It was established in the 1820s. The earliest interments recorded as Mary Wheeler, 1828. Interments occur until the 1850s, possibly into the 1870s. Although I will say that there are a lot of burials within this cemetery that are marked by fieldstones. So it's difficult to know necessarily when some of those individuals were committed to the ground. There are 13 known interments that are recorded on find and grave, as well as in other historical research that's been done over the last 50 years. And those are, so again, there's more than 13, but there are 13 known interments with recorded individuals, the dates they died, that information. This is a cemetery that is part of a larger community, the Little Egypt community, the Den Road community. By all accounts from the history that's been conducted in this area, it was a racially integrated community in the 19th century in western Easton. This is the Clark 1856 map that shows the location of the cemetery in general locations. In the early 20th century, large reservoirs were constructed in the region, not necessarily where we are here. Obviously, we didn't do this underwater, but sort of within some of this area. So some of the Den community is sort of depopulated due to the construction of those reservoirs. 1850 census documents list several families in the vicinity of the cemetery, and then legible headstones within the cemetery include the family names of Baldwin, Wheeler, Thorpe, and Treadwell. Today, the same individuals and their families that are documented in the general region. This is a 1934 Fairchild aerial, so the pointer doesn't work on like an LCD screen. But so the cemetery is here. This is an aerial photograph that was done in the 1930s by Fairchild, where they were taking a number of photographs from the side of low-flying planes that really are this fantastic resource that we have in Connecticut that show a bunch of large areas of our state when it was last sort of clear-cut. It's not clear-cut everywhere, but it helps to identify a lot of these superficial features that have since become overgrown since the secondary growth of forests in the last 100 years or so. So it's a good resource if you're used to looking at these. That's the cemetery there, and it does look different from the sort of grassy areas around it, right? So that's the stone walls that we're seeing there. It's hard to see. The resolution is not what we're used to with satellite imagery today, but it's a really good resource for identifying what these historic resources looked like in the 1930s before they become covered with the secondary growth of trees. So, as I said, there are a number of historians who have done a lot of research at this cemetery, and I'm going to just sort of quickly go over some of their work. This was a quick sort of survey by Marshall Nye in 1973 for the town of Easton. So it's a stylized reconstruction. He clearly came and recorded the number of headstones within the cemetery. A number of those are field stones, but with the numbers here, keep trying to use the pointer, they correspond to the epigraphs or inscriptions that are on each of the headstones at the time. This is really important because, as you might imagine, headstones over time, they continue to be exposed to erosion from wind, water, they fall over. There are a number of things that can happen in 50 years, 100 years, 150 years, where they just no longer maintain those engravings. And so it's great to be able to see what was legible in the 1970s and carry that forward today, too. Again, as I said, a stylized map of the cemetery showing where the Ascatuck River is. All the legible inscriptions are listed for 10 headstones, but 25 markers in total, so keep that in your mind as we move through. 25 headstones in total. Nye also names it as the Din Cemetery, but notes past names as the Indian or Wheeler Baldwin Cemetery too. So it's had a number of names by people in town, in the region over time that Nye records in his brief survey of the cemetery. Moving forward about 15 years, Callista Cleary, a high school student in 1989, did this fantastic survey of the Din Cemetery as sort of a high school thesis project. And it's really phenomenal work, better than many undergraduate theses as well. It's really a really great survey of the cemetery. She conducted historical research into the Din Cemetery as well as the larger community. Here, she's drawn a much more accurate map of the headstones. So not only does she have the individuals on the stones labeled, one is fallen over, she also puts where the trees are as well. There's some question marks, so she's got field stones here. Is this a headstone, is it not? Those are the kinds of things that I put down on my surveys when I do them. When I'm looking at what's in a cemetery, we don't always know what we're looking at, but it's great to record everything you see. Again, she did a large amount of historical research, and all of this presents this as a community of individuals, racially integrated in the 19th century, living, working together, and being buried within the same cemetery. So remember, Nye had 25 stones. 15 years later, there's 23 stones that she noted. 8 of those are carved headstones. 4 of them are footstones. So that's the first time that we see footstones separated out. And then 11 fieldstones. And by fieldstones, I should say that what I mean are those stones that we can, if you look out, I'm sure you can see a stone wall somewhere. The rocks that have been carved and detached from bedrock, moved by glaciers, deposited sort of as a palimpsest across our landscape here in Connecticut, and then used for stone wall construction, as well as often used as burial markers in historical cemeteries. The Din Cemetery is no different from many other historical cemeteries where fieldstones were used in the 19th century, 18th century as well. Moving forward, there was a GPR survey, a ground penetrating radar survey that was conducted in 2007 by Subsurface Consulting Limited. This is the results of their survey here. So we can see headstones They've got datums that they laid out, so datums where they superimposed a grid or a Cartesian coordinate system onto the cemetery and then measured they conducted their radar survey in transects across the cemetery. Unfortunately, the survey, while it looks to be a very extensive survey, their report was only a couple of pages, and so it's difficult to know what the spacing interval was for their survey, which, as you will all learn during this talk when I explain how ground penetrating radar works, is really critical to understanding what we see in the ground. But these results suggest 34, so 34 headstones, which is far more than the 25 or 23 from the previous surveys, and 54 unmarked burials. So a huge jump in number based on the previous estimations. As I said, the survey interval wasn't clearly defined, and I think what's happening is that there are several trees within the cemetery. You don't know it yet because we haven't talked about it, but coffins are made of wood, tree roots are made of wood. That's all the GPR machine cares about when it sees something in the ground and the radar is reflected, is the density of the object that the radar travels through. Because they're both made of wood, they look the exact same. So it's really important to have a standard interval so that you can see a dendritic pattern for roots as opposed to a rectangle for coffins. And I think that's what was happening here, is that the machine and the standard interval is not what we use today, and that's probably why there's a bit of an overcounting. But all surveys are different, all conditions are different. It could be that there was good evidence for these burials too. I can't make that judgment without seeing the data myself. It might have resulted in an overcounting of the graves, but in any case, these 3 or 4 separate lines of evidence from historians as well as Subsurface Limited suggest that there's great evidence for intact graves within the cemetery, many of them where there are no markers today. So that again is not something that's, I think, very uncommon with historical cemeteries. There are, I would say, every historical cemetery that I've ever surveyed has a large number of unmarked burials. That could be for a number of reasons. One, individuals, when they're buried, might have an organic marker. Think of a wooden cross, some other type of marker like that. Those decompose over time. It may be that cemeteries, particularly towards the middle or end of the 19th century, go through a lot of beautification projects as well. We start thinking as a society of cemeteries as places to picnic, to remember our dead, which is not really something that happened before the Civil War as much. And so that causes a lot of organizations to clean up their cemeteries, and when they do so, they reorder where some of the headstones are, and so some of them get taken down, moved, and that results in unmarked burials as well. There's a number of reasons why we might have unmarked burials within a cemetery, but the end result is that almost all, if not all, historical cemeteries have numerous unmarked burials within them due to a number of these reasons. And I should say, too, that if you guys have questions while I'm talking, please just raise your hand and I'll be happy to answer them. So, to summarize, there is, I think, not more than a fair, there's a lot of historical research that has been conducted to date at the cemetery, more so than most of the historical cemeteries that I work in. These include in the 1970s, 1980s. There was another survey that I haven't talked about in 1996, the GPR survey in 2007, and then an archaeological town-wide survey by Reeves, Silvergrade, and Bongenna in 2009, where they spent a fair amount of time not only on the cemetery but in the larger community as well. But that brings us to 2024, when the town of Easton and the cemetery committee applied for a Connecticut State, this should be it here in the chapter, State Historic Preservation Office Geophysical Survey Grant. This is a fantastic grant program that our State Historic Preservation Office, it's one of the only State Historic Preservation Offices that I know in the country that offers this. they offer non-matching grants up to $5,000 for 1 acre of geophysical survey of historical cemeteries. So that's critically important for resources like cemeteries, where private cemeteries, all cemeteries, the only money they can make is by selling plots to bury people within them. A historic cemetery like this that no longer has active burials cannot bring in any funds, and so it's hard to produce the funding to do these types of surveys to identify where burials are, and SHPO has recognized that need and created this grant program where municipalities, nonprofits, historical societies can apply for this. And I don't believe it's limited to one time ever. You can apply each year for these types of surveys and survey up to 1 acre of a historical cemetery. The process takes a little bit of time, but it is a really fantastic program that SHPO has put forward. So,
Excuse me,
yeah,
you mentioned that letters for it, and then you said there was a typo or something there. What's the actual?
CTSHPO. That is
CT.
the acronym. The Connecticut State Historic Preservation Office. They're housed in the Department of the DECD. I don't remember what that acronym stands for.
Fine.
Yeah, CT SHPO. So, I'm an archaeologist. And I'm gonna, no, sorry, go ahead.
On that, on the grant that you're talking about
Yeah.
there, is that for only inactive cemeteries?
No, it's for historic cemeteries. They can be active. They just have to be historic. So by that they mean burials that are over 50 years in age. That's all that matters.
Well,
And-
that fits the building, because we've got revolutionary.
Sure.
I'm from Union Cemetery,
Yep,
and they have revolutionary burials there,
yeah,
so we could,
you definitely could. I mentioned it because I thought there might be some people from cemeteries in this audience, so people might be interested in it, so, for sure. If you go on their website, it's under the 2024 Survey and Planning Grant Documentation. There's a PDF that you can download. It's sort of hidden within that document, but if you do a search within it for the word geophysical, you'll find it. I think you need to be in touch with Mary Dunn at SHPO. She's the person to contact about this. Or Corey Atkinson, who's an archaeologist. They'll both point you in the right direction.
And you said that's under the DECD?
Yeah, but if you Google CT
Department of
SHPO.
Economic and Community Development.
Right, sure. I'm sure that's what it is. So, let's talk about some of the ways that we as archaeologists have, we didn't invent, but we just borrowed from other fields, these remote sensing techniques so that we can identify burials. I mean, there's other ways to identify them. You could simply excavate the soil, remove the plow zone, and see where the grave shafts are, right? That's very invasive, though, right? We don't want to do that because it's incredibly invasive, and the point of identifying these unmarked burials and marked burials is to protect them, right? So instead, we use remote sensing techniques, and by that I mean techniques that do not do any damage, that we're remotely investigating these resources. So ways to map cultural resources without excavating. And that's really important as archaeologists because whenever we excavate something, we are destroying that piece of information. We're taking lots of notes, we're learning about it, but excavating the site, not a burial site, but even an archaeological site, is an act of destruction, right? And so one of the things that we try to do now is employ these remote sensing techniques so that we're not destroying these sites, but we're learning a lot of information about them too. So there's a number of ways. We're going to talk a lot about ground penetrating radar, metal detection. Those are, again, think more like battlefield sites. Magnetometry, measuring the magnetic fields of things that are buried within the earth, sort of like metal detection, but more sensitive. Uncrewed aerial vehicles, or drone flights, are a really important way to do it. You can do that through just normal cameras or thermal cameras too. You wouldn't think it, but grave shafts give off a different heat signature than the surrounding soils around them. LiDAR is important for everything that we do, light detection and ranging. It's a laser technique where a plane or a drone is flown over a survey area, and millions of pulses of light or lasers leave the emitter. In nanoseconds, they leave it, hit objects to the ground, and bounce back up, resulting in this sort of bare hillshade model where I've removed the trees from it. This is over in Reading, actually, for an archaeological survey that we were doing of this land along here. Also, cadaver search dogs. There are 7 specific scents that are associated with decomposing humans that are unique to humans and not to other animals, or so cadaver search dog organizations say. I mean, it varies from dog to dog, but I have seen and worked with a lot of cadaver search teams where they're really effective at tuning in on unmarked burials. They do far better for more recent burials than they do for historic ones, but I have seen it work with historic burials as well. Not to the level of ground penetrating radar, but to sort of give you an area. If you're looking for a cemetery in an area over like 5 or 6 acres, the dogs can help zero you in on that area, or like a dead raccoon, which has happened a bunch of times. I don't think we can fault them for that.
Now, they can smell through the vault?
Yeah, well, because a lot of the vaults are not intact, right? So because of pressure from the soil above them, or tree roots, or a number of other frost heave that's happening over hundreds of years, a lot of the vaults or the coffins are decomposing, and therefore those smells can come sort of up. And in fact, the best time of year to do it with dogs is when the ground is a little bit frozen, because what that does is create a lot of air voids within the ground and bring that scent up to the ground too. That's not a great time to do ground penetrating radar, but it's a great time to do cadaver search dogs. So, yeah.
Interesting.
So if we start looking at some of these techniques, we didn't employ them all, but we employed 3 of them in this survey. We look at the cemetery using LiDAR. This is a statewide survey that anybody can look at. You can go on, if you just Google LiDAR Connecticut, there's a viewer from CT Echo where you can go around and look at the bare earth hillshade that has been created. This is the stone wall here. That's the slope down to the river. There's a number of other interesting features. There's a cellar right there that are in the area showing the deep history that the community had to this region. It's hard to see here if I had a different way to show it. That's an old mill foundation there. We also did ground penetrating radar, so that's the machine that we use with the cemetery in the background. And as well, we flew a UAV at the site. You'll notice that there's a lot of trees, so we didn't fly it very high. It was only about 10 or 15 feet in the air. I'll show you another image later, but this is a really high resolution image of the cemetery compared to what you can see from the satellite images, right? So underneath of this is the satellite imagery from space versus what we can create when we use the drone. So before we do anything though, when we start these surveys, we do a conditions assessment. And that's what we did here. So we did a high resolution global positioning system, recordation of all the markers, stone walls, anything that looked like it could be related to burials within the cemetery. What we identified were 8 headstones, 5 footstones, so we're up to 13 now, 17 field stones, so that's 30, and then 1 rock cluster, so 31 potential marker stones that we identified when we did this survey. We also found 10 sort of person-sized depressions, right? So not all coffins hold up over time. When they start to decompose, that causes the soil to shift and creates a lag depression. I believe that's what many of those are. It doesn't take a stretch to see that. A lot of them are associated with fieldstones or headstones, right? We also saw some crop marks too. Those are mostly outside of the cemetery. There weren't any that I identified inside of the cemetery. And by that I mean different vegetation, right? So something different about the vegetation, different types of plants that are growing, or they're drier versus the surrounding, or greener versus the surrounding vegetation. And that's again because you have to think of what we have here. It's a grave shaft. The way that water moves through the soils is different with those features than it is for the surrounding soils, which can attract different types of vegetation. Roots are attracted to those types of soils. It's easier for them to move through soils that have been dug through and then backfilled because the soil is softer, there's more air in it. The same thing is true for the roots of small plants too. So that's just sort of at the beginning what we look at. So 31 physical markers, but then 13 other ones too, right? So now we're up to sort of 44 sort of areas. As I said, we flew a UAV over the cemetery. This is the resulting bird's eye view of it. So if you were up about 15 or 20 feet above it, it's just an example of the type of drone that we use to Mavic 3E. Here we can see, let me orient myself. Yeah, the barway is here where you come in. So headstone, headstone, headstone. That's a tree trunk. So the trees are actually, they're live, but I cut the tops of them off. Headstones, there's a rock cluster. Headstones here, there's footstone, footstone. This shows you an image of where the pictures were taken above the cemetery. So we use these with like a 40% overlap field of view of each of the pictures so that I can stitch them together with another program to create this mosaic image. We can do more than that though. We can create a three-dimensional model of the cemetery, and that's what this is. So it's just like LiDAR, but instead of using the laser technology, which is very expensive, we use pictures to do the same thing. So we're using this digital photogrammetry for the overlap of the pictures to render a three-dimensional model. And what we see, it's sort of hard to see, but these are some of the depressions here, here. And if I were to tilt it, you'd be able to see them. And as I mentioned already, this subsidence or slumping occurs when coffins decompose over time or deteriorate. There's an example of three of the clearest depressions. And it's particularly common in burial grounds where there might be individuals who were buried in shrouded burials, so by that I mean without a coffin, or just in historic cemeteries where there's a number of things that are happening in the 19th century. Before the railroad is invented, we're running out of wood here on the East Coast, right? Before the railroad is invented and opens up the West for bringing lots of timber back to the East Coast, there's less and less available timber in the Northeast, and so coffins get thinner and thinner over time too, and they're more susceptible to decomposition, particularly in the 1840s, 1830s, before we start to get the big timbers from out west that are being shipped back here via rail. We also, I'll just show you, look at later, from that three-dimensional model, we then 3D printed the cemetery here too. So the headstones and the trees are clearly evident there.
Excuse me.
Sure.
You had mentioned that the imaging that you have there would show up with this sunken, the slumping of the grave. And you have wooden coffins, where in the beautification of cemeteries, after a certain period of time, these slumps were constantly filled in with backfill to make them level. Would that show up on radar, the different levels of backfill?
Yeah, so yes, it would. What you would have is, I don't think that we have that here, but if cemeteries are beautified and people do level those slumps, you would be able to see a layer, it would look different versus the surrounding intact soils around it. What you would see is it'd be very faintly reflective for that depression, and then you'd have higher reflective stuff that's filled in it. You'd be able to see it. It would be very shallow though, and it would also, in New England, and anywhere that's not the Connecticut River Valley or the Housatonic River Valley, we have lots and lots of rocks, right? They're everywhere. Those rocks complicate the interpretation of radar because they're within the entire soil column. But also, when people excavate graves, they take those rocks out too, right? And they don't generally put those rocks back into the grave when they backfill it. And so what we often find with the first, I think in centimeters, so 10 to 20 centimeters, which is 4 to 8 inches of the ground. In a cemetery, there are rocks everywhere, and that's because there's ejecta from the excavation of graves that over 100 to 200 years gets just sort of spread about the entire cemetery area. So I think that I would be able to see what you're talking about, but I think it would be complicated by all those rocks that are almost always at the surface in New England graveyards, which sounds like it's bad, but it's not. When you don't have clear walls like this, it really helps me identify the boundaries of the cemetery because I've got that ejecta pattern and it disappears. When you get away from the cemetery, where nobody is excavating a bunch of graves, you stop seeing it. You just have a normal soil profile where the rocks are mostly 2 to 3 feet below the ground. And so it's really helpful in that regard, but it complicates what I see at the near surface too. So it's a great question. So what we ended up doing was create this final orthomosaic of the cemetery. We did not, so we conducted radar outside of the cemetery walls too, but it was just too dense with trees to be able to fly it in that area, because if you don't fly drones for a living, you might not know this, but what they really want to do is get stuck in trees. It's like they just really want to do it. So my UAV pilot was pretty nervous the whole time, so I let him decide, what he was going to do. But this creates a highly accurate rendition of the cemetery, where the pixels are accurate to the millimeter, basically. So it's an incredibly accurate rendition of the conditions when we did the survey. We also did photogrammetry of headstones too. So it was hard with the ones that were here on the wall because I couldn't really get back to get the subject in the photo, but the Treadwell headstones here, which have 2 field stones behind them, presented really excellent opportunity for this. And so this is a digital record of what these headstones look like. The one rock cluster is behind this headstone here. So Polly and Beach Treadwell. Polly, this is the inscription, died August 25th, 1872, aged 25 years, 2 days. And Beach died July 9th, 1838, aged 23 years. This is how I create that image. So this is just a snippet of it. It's not the 3-dimensional model. I've just taken like a screenshot of it. But it's the same idea with the UAV survey. I'm simply walking around, taking a number of photographs. And here you can see what each picture looked like as I did it. They're overlapping, as I said, about 40 to 50% of the field of view of the camera. And they envelop the entire subject. And so this, I've removed the colors from it now, but it should turn for me. Yeah. So there's the 3D model. There's the rock cluster. These are the field stones. The models for the field stones didn't turn out as well because I was more focused on the headstones themselves. As that's turned out, there's going to be. And so we can do high resolution imagery of some of these. Because PowerPoint doesn't handle big files really well, I had to decimate the mesh, but you can actually see some of the engravings on them really well, too.
Would that be seeing the engravings, one that you, with your eyes, you cannot necessarily see, but that you would actually be able to read some of those?
So, yes. Depending on, you have to use incident lighting to do that too, though. So it's hard to do in this area because there was so much cover. But if you use a large mirror, you can direct the just incident light to it and create a much more accurate ability to read the headstones. There's also a technique called raking, RTI, that a colleague of mine, Kurt, I forget his last name now, but he does this, and he can really, what you're talking about, he can really see things that I can't see when I do this sort of quicker photogrammetry. There are ways to do that, but it's a larger setup, and you need not only a mirror, but like your own steady light source to do it. So it's a bit more complicated, but you can do all of that. It's very different than it was, say, 5 or 6 years ago. you would have to bring a generator out or something like that. Now you can just go to Home Depot and get a Ryobi lawnmower battery, plug it into an inverter, and have power on site too. So there's ways to do this that we never thought possible 7, 8 years ago without bringing lots of machinery onto sites too, which can be really destructive because it's heavy, right? So there are ways to do that. It's just I don't do that technique. It's a sort of rabbit hole that I haven't gone down myself here, but it is possible. Okay, so those are all the things that we did before we did the GPR survey, right? Before I go into the results of the GPR survey, I want us to sort of be on the same page of what you can see with GPR and what you can't see with GPR. I would say that ground penetrating radar is by far the most widely used application of geophysics to archaeology. That's for a number of reasons. But one, it's cheaper than a lot of the other ones, so that's important for archaeologists. But two, it has wide applicability for what we are interested in, which is generally things that are buried between, let's say, 4 inches to 5 to 6 feet beneath the ground. A ground penetrating radar machine is a machine that emits a pulse of electromagnetic energy into the ground, or into the air if you use it from a drone, or into the water if you use it in a canoe. Those last two aren't widely used, but you can do them that way. The radar, as sort of a wave energy, leaves the machine, travels as an expanding waveform, and so it's getting larger, and we think of it as this cone of penetration at depth. That's important because it's not staying at the same rate, right? And because it's not the same rate, it is difficult to understand how deep something is because of the physics of it. So that distorts the depth of objects within radar. The radar energy is reflected, amplified, or absorbed by the material it's transmitted through. That means that it comes back, it disappears, or it speeds up. We have a computer on board the machine that records the strength of the signal that's emitted and reflected, as well as the time in nanoseconds, so it's very quick for the reflection to leave the machine and come back. So even when I use a 200 megahertz antenna, which goes 25 to 30 to 40, 50 feet deep in some settings, it's still in nanoseconds. It's happening immediately, faster than we can even think about it. And so, that's all very theoretical, but let's just watch how it works. As I said, it's active, it's non-invasive, that's important. It records the dielectric contrast of subsurface materials, the differences in how water travels through sediments. That's what I'm talking about when I say the dielectric contrast. So water is percolating or moving through a system, such as soils, and it leaves behind little chemical signatures that are different for the different layers of the earth or the materials that are in the earth. Here, the machine is moving. This is a coffin, this is a grave shaft, these are plow zone soils next to it. And so that's the interface of the plow zone versus the subsoil. Here, we've got a metal coffin, but there's more, right? It's not just the metal coffin, it's this faint X here, where the radar, if I go back and do it again, the radar that's coming out of the machine hits the trench here, because it's that cone, right? And here it is too. So these tails are indicators of this trench, and that's important, even though there's nothing there, right? The trench wall is really here, but it's seeing it farther away than what it really is, and creating this ghost image. What radar does, it's not a real soil profile like an archaeologist would cut back and look at the soil, but it's a proxy for it, right? It's a way to see it without actually physically having to excavate. And this is, as I said, plow zone soils here. By plow zone soils, I mean an A-horizon, like a humic, just sort of thin, organic-rich topsoil that's been mixed by plowing or other human activities with the subsoil or the native soils underneath of it. And that's what the trench looks like for the grave shaft too. It has mixed subsoils with topsoil in, and that's why it looks different from the surrounding natural soils. Yeah.
Is there an advantage during a drought year or a wet year to doing this?
Yeah, so it's critical to understand what the soils, what the water content of the soils are before you do your survey. If it's flooded, so if it's soaked, if it just rained like a bunch like the last 2 days, it's not, you can do it, but you'll get horrible results because the water saturates everything, and water is the slowest medium that radar travels through. It's like the next slide that I was going to do. Air is the fastest medium that it travels through, and it can't travel through metal, right? That's the whole idea. The whole growth of radar is from a little bit before World War II, but it's to see objects far away that are made of metal, right? That's the whole impetus behind radar, is to be able to identify where those ships are, where those planes are, because the signal that leaves hits the metal and bounces back. It does not penetrate. It does penetrate water, but it makes the radar so slow that the signal just dissipates. But if you were to wait a day after it rains and it dries out, all of this area here dries out and it's pretty good. The coffin, if it's wood, soaks up that water, and then it shows up really vibrantly in the radar signal. So it's really, the best time to do a GPR survey is not during a drought. It's 1 day or 2 days after a big rain, because it makes the coffins really jump out at you. Can't always do it that way, but that's the best time to do it. So this is a cheat sheet that us GPR people use to show you the relative dielectric permittivity of different mediums. So again, there's no one soil that's all silt, all sand, all clay. They're almost always a mixture of these things that we see here, but we're seeing it from the fastest fastest medium, air, versus the slowest freshwater or saltwater. The greater the permittivity, the slower the radar moves through it. And as I said, metal is entirely reflective. All other substrates are between those values of 81 to 1. And so it's a mixture, and we have to calculate this using the machine whenever we conduct the survey, because that helps us identify the depth of which targets are, which is really important for burial grounds, because we want to know how deep the tops of the coffins are in case, we just want to know, but also if in case they're going to be impacted by erosion, those types of situations. So that's like a bunch of ways to think about it. Let's watch it happen. So imagine we're in a cemetery. We don't have any headstones though, but we're pretty sure that there's a bunch of burials under the ground. This is just explaining the physics of what I was talking about, right? That cone of radar is bigger, so the buried object, it sees it before you're over top of it. And so while this buried object is really a pipe and it's circular, it looks like this parabola because of the machine moving towards it, seeing it at a shallower depth, and then at a deeper depth, and then a shallower depth. So my bearded friend will move here with the radar across the screen. Yeah, quite.
But at Dead Cemetery, there are no metal graves, right? It's all wood?
I think so.
Yeah.
But
Yeah,
there
it's
could
not
be,
metal.
yeah, I mean, I didn't see anything that looked, there was nothing that looked incredibly reflective like a metal
Yeah.
grave, but they're very common in 19th century cemeteries. So they're not everywhere, they're not ubiquitous, but brick vaults, and then stone vaults sometimes, and metal coffins are common in cemeteries.
It's mostly wood there.
I believe so, yeah. A lot of the coffins I think are partially decomposed too, which just happens through time.
Yes.
So, yeah. So he went across with the radar, and then what we would see with this. So this isn't just coffins; it's the grave shafts too, right? It looks like this. So a bunch of these parabolas here, but also a bunch of those X's for the shafts above, right? And so when we're doing this survey, I'm not just looking for this, because that's wood and it looks the same as, the tree roots, right? We have to identify the crosses for the shaft as well. It also helps, they're all sort of at about the same depth. Most historic cemeteries are not at the adage that we think of at 6 feet. Some of them are, but a lot of them aren't, and that's again, here in New England, there's rocks at 6 feet. There's bedrock at 6 feet, right? So 3 feet, 4 feet, 2 feet sometimes, 1 feet sometimes, and that's not necessarily how deep they were then, it's that there's erosion that's happening at the time. The way we read this, the top is the distance that the GPR machine traveled, or time, or the number of scans that it conducted. And then this is the depth, but it's really the time in nanoseconds, and I've transformed it into the depth. So remember, this parabola for the top of the buried object, that's what we're seeing, are those parabolas, like you would in like an algebra class. But again, that's not what a coffin looks like. It's not this curved thing, right? So these are really the coffins. They're these rectangular shapes within there. But these tails help us identify where the tops actually are. So that's, in a perfect scenario, how it works. And this is just another way to view it. So the machine is going over top here. This tail is created as we're farther away. Then as you're over top, you're at the very top of it. And then you get the tail on the other side. So I'm going into all of this detail. One, to show you the amount of physics that goes into identifying these objects, but two, so that you can see that it's not just the object itself, it's other, I mean, the tail isn't real, but it is important, versus the cross here, which also isn't real, but is important for the shaft as well. There's a number of these identifying features that are critical to identifying the graves. But most of our scenarios are not just a bunch of graves perfectly lined up with no other things in the soils. There's a lot of other objects that are down there. I haven't mentioned them yet, but groundhogs love cemeteries. Again, the soils are softer in cemeteries than they are anywhere else, so it's a great place to make dens, right? And the den cemetery is no different. There were groundhog holes that I could see while I was in the cemetery. Most of our settings are complicated like this. And so we're seeing the amplitude of reflection of the radar. It's strong here with this buried foundation from the historic house. It's weaker just within the soils, strong off of this coffin here. Again, complicated, a number of things, also tree roots. And so there's also several layers of sediment too. If we were to look at this in radar, it might look something like this. I've taken 3 different sites and smashed them together. This is a foundation, so you can see it looks very different than a grave, right? You can imagine this is the foundation for a house. It's been dug down, it's really complicated. In the middle, where people filled it in over time and a bunch of their trash from, not when they were living there, but when the house burned down or was disused, the person who was farming that land then didn't want a big hole in the middle of their farmland, and so they filled it in over time. Another grave here, and then I've said it a bunch that coffins look like tree roots. You don't have to take my word for it. These are all tree roots in one profile. They look exactly like coffins, right? And so that's what we have to sort of sort through, and we do that by making sure we space our intervals for the survey at a tight enough interval that we can identify where these are. Because again, the coffin is a rectangle, and these are almost always at a 45-degree angle. We should be able, if we space our survey intervals tight enough, to see that the roots are going down like this versus a coffin that is flat. And so, as a radar specialist, the first question that we ask when we get onto a site is, what are we trying to find here? If I'm trying to find a house that's, a giant 25 feet by 30 feet foundation, I don't have to space it very tightly. I can just even do wildcat surveys and go back and forth until I find it. That's not a great way to do it, but I could do it that way. Coffins, though, are small. They're between 3 and 7 feet in length. They're made generally, especially in the 19th and 18th centuries, they're made for individuals, and so children's coffins are much smaller than adult coffins. They're 1.5 to 2 feet wide. So we have to space our intervals so that we intercept those several times. Cellars are much bigger. 10 by 10 feet are usually the smallest ones. Posts for a house or sort of an indigenous house are small. They're this big, right? Maybe this big. So if you're going to get those, you have to have a really tight interval. The same thing for other indigenous features. Hearths, roasting platforms. Those are incredibly small sometimes, and so you have to have a really tight interval to be able to identify those. Again here, we're talking about coffins, so let's look at them. You also have to, so here, I've helpfully laid out the transects at length. These are metric intervals, so this is 50 centimeter, 1 meter, 25 centimeters. 25 centimeters is, can't think in inches. 10 inches, right, 10 inches. And then here we're at 20 inches and about 3.5 or 3.3 feet there. But that's if I'm perpendicular to the coffin, because we're assuming that the coffins have been laid out in east to west fashion. That's probably true. Of course, magnetic north migrates over time, right? So over a 200 to 300 year period, magnetic north has moved something like 15, 17 degrees. And that's the way people were generally measuring it, was through compass bearings. So it's just different than it was 150 and 200 years ago. Also, because of space, because of a number of other conditions, people might not be buried in east to west dynamics too. So if we are perpendicular though, and we've got a 50 centimeter interval, I just missed it here, right? But I only got it twice. If we do 1 meter, I only hit it once. And if we do 25 centimeters, I keep pointing this toward 1, 2, 3, 4, 5 times I hit it. So that's important if I want to see the shape of it, right? The more times I intercept it, the more times I see it with the radar, I can identify the depth, and I can produce a map that shows it as a rectangle versus those root systems too. And so that's generally the encounter rate that we're trying to interact with is about 25 centimeters. You can do it at smaller intervals, although, again, we talked a little bit about New England and all the rocks that exist in the soil. I have found in New England, if you go to a tighter interval, what you often see is a lot of those rocks, and it's not helpful, actually. So imagine if you're at the Louvre looking at the Mona Lisa, you don't want to be too close, you don't want to be too far away. There's a prescribed distance that you should look at that painting, right? And the same thing is true for radar. There's a prescribed distance that is the best to identify these objects, and it's about 10 inches or 25 centimeters. So, now we all are on the same page with radar. We don't have to talk about the physics anymore. I'll give you an example of really intact coffins from a burial ground in Falmouth, Massachusetts. It's not just that they're really intact, it's also they're in complete sandy soils, which is one of the best mediums for radar to travel through. There's no rocks in this area whatsoever. This is just to show you what it can look like. Here's the oldest headstone that we did for the ground tree of. And so what we're seeing here, this is an individual profile. This is what I call an amplitude map that's slicing down from the surface, okay? So we're going down, we're now at about a meter, and you can start to see the rectangles coming out as the high amplitude reflections. I've taken all of those profiles and stitched them together to make a three-dimensional map or a plan view that goes down beneath the earth. And you don't have to be a radar specialist to have seen that those were all graves, right? And that's what we're trying to do with the 25 centimeter spacing, is to produce maps like this so that anybody can see them. And this is where I've just taken one example. This red arrow is this profile here that goes over top of these graves. And you also don't have to be, you don't have to be radar. It's a little bit hard to see maybe, but there's a bunch of green rectangles here that we identified in our UAV survey. Those are those prop marks that I was talking about. So with like a 5-minute drone flight, we identified 200 to 300 of these unmarked burials that night too. Which is a bit humbling because the survey took a lot longer. So that's radar. That's an example of what it can look like. Let's look now at the Den Cemetery. We conducted 2 surveys, one completely within the bounded walls of the cemetery, and one outside of it immediately to the west, a little bit to the north, a little bit to the south. We were not able to survey here. It's a little bit sloped there, and there were numerous trees, very large trees that were here that made it hard to do. Same thing here, the slope goes immediately down, there's also large trees, so weren't really able to the Assunpink River to survey there. And here, the slope is precipitous going down the river. So these were the only areas that were sort of surveyable via GPR, a large area to the west, and then completely within the cemetery itself. This is to show you the transects that we conducted. So these are those individual transects here. This is within the cemetery. This is blank because of the walls. And then there were, the wall is here as well. It's a little bit, looks a little bit larger than it is, but this is right where the barway is. So the wall is a little bit exaggerated on this map. 134 individual transects. And so when we're doing this, we're carefully measuring the start and stop. This is a headstone. Here's a headstone. The headstone is here, and here, and here, here, and here. So we have to move the machine on the other side, go around. That's a tree, that's a tree. There's a tree there as well. There's only about 0.2 acres that were surveyed in total, but we surveyed everywhere that we thought there could be burials. We did that 25 centimeter or 10-inch interval. We also, I didn't talk about it, we only go in one direction. That's because the surface of the earth, as you can all imagine, is curved. And so if I start on this baseline and I'm going this direction, and then I were to come back this direction, when I go over top of objects, if there's a big curvature within the grid, I'm going to go over top of that object at a different distance, right? I'm not going to be in the exact same position when I go over that buried object. And that really matters if what I'm trying to do is image where that coffin is, right? And so that's why, I mean, I can't say that every distance we travel is the same, but I'm controlling that as best as I can by having a standard baseline that I move the machine across, so that I'm at least removing as many variables from creating images that don't really make sense.
Because of that, can you do radar on slope?
You can. It's just when you do radar on slope, what it does, there's a number of things that are confusing to some people. So because you're going up, the cone is going into the slope at a weird angle. But as long as you have the same baseline, you're still traveling the same distance, right? Or about the same distance. But you have to often reverse the images of what you're looking at. So if we're going up a slope and there's an object buried within the slope, what you're going to see is sort of a reverse image of the profile of what it really looks like. And there's ways that you can, if you measure the elevation of the start and the stop, you can sandwich that profile in so that it makes sense and you can view it that way too. You can also use really accurate GPSs to track your position. So like the Department of Transportation uses a network of base stations with GPS with like 1 to ½ a centimeter accuracy everywhere. You can do that with radar, and then you don't have to do what I'm saying. But you can't do that where there's a bunch of trees, because the GPS won't work that way. You have to do it this way under the tree canopy, because there's no way for the satellites to give you those corrections to know where you are with any. I mean, you can know where you are within like 10 centimeters, but that's not good enough. So there's a couple of definitions that I just want to go over of the ways that we at TerraSearch identify burials within a burying ground. When I use this term, probable marked burial, what I mean is that if there's clear geophysical evidence, there's a tight parabola, there's a faint cross above it that shows the trench that was dug, and then there's also a headstone that I found. So, I can't say 100% in anything, but I can say it's really 100% that that's a burial. It's associated with this headstone, so that's why I call it a probable marked headstone. A possible marked headstone is one that is missing some of those indicators. There's still a headstone, but maybe the reflections are weaker here. Maybe I can't see this reflection at all, but there is a cross. So like here, this is one that we call a possible one. This is one where there's a cross, but there's no burial, so it could have been an individual that was shrouded burial, or what I think, it's an individual who was buried there, and then somebody came and dug that coffin up and moved it. So it's a disinterment pit, and that's why it looks so clean too. We didn't have any of those in the Den Cemetery, but you do get those sometimes. A probable unmarked is one that looks just like this, right? They're really clear, but there's no headstone. So again, I'm very confident that it's a burial. A possible unmarked is there's no headstone, and it has weaker geophysical evidence. And then I've already talked about the depressions, but the crop marks are other indicators that aren't geophysical, such as a superficial depression or a crop mark that shows a clear burial too. So here, this is a cemetery in Mansfield, Connecticut. I mean, these are associated with headstones, but there are very clear crop marks where the patches of grass are much drier than the surrounding area, and that's because there's a grave and a coffin right there. And I know that because I did a GPR survey as well. But again, the drone was able to do this within just like 2 or 3 minutes. Sure.
Were the coffins always separated from one another, or were they ever abutting?
Oh, sure. They're abutting. They're on top of each other sometimes. They're cross-cutting. So this one is, so here, they're next to each other, but they're sort of over top and overlapping too. And that's because where you bury people is only as good as the people who are digging the graves have maps of it, right? And so what you can do, what people often did was they would just sort of make a large hole in the ground until they start to see the grave shafts for previous graves before they get down and they dig it next to it. But sometimes they'll be on top, sometimes they're next to them. They're not always in perfect rows, and a lot of that owes itself to the mechanisms or the manners in which people are interred in the 18th and 19th centuries, usually by family members, or there's not professional excavators at cemeteries until the 20th century, sometimes into the mid-20th century, where it's somebody who works at a cemetery who's doing it, right? So you don't start to see the really clear, non-overlapping grave shafts until much later. And that just has to do with the number of those things. Yeah. Sure.
Did you find as an archaeologist in doing this research that there would be, I know you said that many times graves would be dug anywhere from 6 feet to 1 feet. Have you found in your research that there's 3 feet would be much more common than, say, 6 feet? I mean, I wouldn't want to say 6 feet.
What I would say is that it's much more common for them to be shallower today than it is for them to be dug at 6 feet. But a lot of cemeteries, like the Den Cemetery, have undergone a lot of erosion over the last 100 to 200 years too. So it's hard for me to say how deep they actually were when they dug them, right? Because there's a lot of soil loss. Now there could be soil gain in some cemeteries too, because that soil has to go somewhere. But I would say that generally they're not 6 feet. Generally they're 3 feet. Generally they're 2 feet. Sometimes 4. I've seen them at 6 or 7 feet sometimes, but that also has to do with maybe soil being added to it. Yeah.
I'm pretty sure that our excavator tells us that the state requirement is now 4 feet.
Sure. Yeah, I mean, it's not the same. It's different for all states too.
Right. But this is the state of Connecticut.
Yeah. Sure.
Is there a corollary between the 6 feet and the fathom of 6 foot?
There could be. I don't know. I mean, I think it's just my understanding is that it's one of those sort of inherent inherited wisdom things, that's the depth at which you bury individuals, in the same way that generally Christian burials are east-west, so that individuals will rise with the rising sun for the rapture, right? Again, that's not the way they're always buried, though, right? The same thing with the depths, too. I don't know the etymology of the 6 feet underground.
The 6 feet actually came from English history, from the bubonic plague in 1665. And they were burying in very shallow graves, and the rats were getting in there.
Sure.
And then the fleas on the rats were spreading the plague.
Yeah.
So under English law, they mandated that you be buried 6 feet down.
Okay.
There are only 2 states in this country that require 6 feet. Massachusetts only requires 24 inches. A lot of rock.
Yeah.
Well,
Well, and again, a lot of them are not very deep. I mean, that's, right here, we're looking at 50 centimeters. That's 20 inches. Yeah.
In what year did either the town or the church require, paper records of burials?
Oh, I don't believe, I mean, I know that those are required now, but I don't, so a lot of cemeteries in Connecticut, in New England, in the United States are, some of them are public, some of them are private. There's a move in the 20th century in a number of states, in the early 20th century, to stop the burial, to professionalize burials, right? To move them into a professional sector where private cemeteries or public cemeteries or churches or other organizations are burying individuals in no longer small family plots. But I don't know when those requirements are. I know that there's a great deal of records that do exist for 19th and even 18th century cemeteries, but that depends on the town, that depends on how well those records are kept too, so, yeah.
I know you're speaking primarily about the historical cemeteries.
Yeah.
But how does a urn affect the radar?
Sure. It depends on what the urn's made out of, right? So cremated individuals, if the urn is, they're not usually very deep, they're usually very shallow. If it's made out of metal, it's super reflective and you'll see it, but they're not very big. And so you can miss urns, certainly, with surveys that aren't at that 25 centimeter prescribed interval too. But those are challenging to identify because they look so different. And because they can be made out of a number of different things. Also, I mean, there's lots of burials now where individuals are buried in a shrouded burial to decompose and be part of the vegetation. I wouldn't say those are impossible to identify, but they would be incredibly challenging to identify because it's vegetation that you're seeing, right? So, yeah. Okay, so we've all come a long way with the history and the radar and how we're doing the survey. Let's talk about what we actually found. I think that the GPR survey was incredibly productive for the Den Cemetery. While there were numerous obstacles, headstones, trees, some stumps, and the tree roots can make the interpretations very difficult. In spite of these obstacles, the burials were reasonably well preserved. And here, I'm jumping towards the end, but these are the identified probable, possible, marked and unmarked burials, as well as those superficial objects, so the field stones, headstones, footstones, crop marks that we identified during the survey. I'll go through those results now. This is grid 1. So looking here, you can see that dendritic pattern of the roots. That's at the very shallow surface. We're going from 0 to 220 centimeters beneath the ground. We're starting to see burials here and here. There were some up here a minute ago, but I missed them already. So those highly reflective images are the coffins. If I were to stop it, you'd be able to see, here's another coffin there. What's important though is that as we were going through that, you could see the root pattern that came out like tendrils at the beginning, and that's what I'm talking about here. We've got a couple of other burials here, a little bit deeper. Some of what we're seeing though is maybe not because I saw that those burials were there earlier. We can also see reflections that are at depth that aren't really the burials themselves. But it's important that that's the first thing that I look for when I process a data set. I know there's trees. If you see the roots, then you know that you've done your intervals at a tight enough interval with which to see the roots, remove those, and find where the coffins are. So this is just showing you at 30 to 40 centimeters, some of these highly reflective areas here, here, here. Here we are. The white is what's really reflective. It's the radar speeding up through that material that we're looking at. So not all of these are identifiable at this depth. Here we're starting to see a shadow because we're already beneath it, even at 30 to 40 centimeters, which sort of gives the game away a little bit, but a lot of these burials are very shallow. That's what it looks like in plan view, but really the data is here in profiles. Grid 1, this is a transect immediately inside the barways here, going this direction. So this profile moves from 0 here, this direction, and we intersect 10 burials on this one profile. We got them on previous and later ones. That's how I know that they have this rectangular shape. But you can see that these are very shallow. Here, they're only at 20 to 50 centimeters. And here there's some really clear ones, all the way down here, past the marked headstones. Only 2 are marked by headstones. One is actually where there's a fallen headstone, so I think it's fair to say that that's also, I called it a possible marked grave, but it's probable, I think. 7 are unmarked, and they have very clear reflective hyperbolic indicators. Importantly, they were not associated with any of those root patterns, which are everywhere in this profile. That's a root, that's a root, that's a root. There's a root here, here as well. So the roots are everywhere, which made it challenging to separate these out. There's also some vertical interruptions, the faint X's above them. However, there's not a lot of depth there, so it's hard to interpret that vertical interruption because the grades are so shallow. Here we're moving this direction, so moving to the east across the cemetery. There's 3 adjacent burials. 2 of them are marked. 1 of them is unmarked. Again, pretty clear here and here. These likely have, especially this one, an intact wooden coffin. This one as well I like as an intact coffin. The tops of the coffin, as I said, are very shallow, 8 to 20 inches below the ground. But again, there's a slight slope here, and so it's not hard to imagine some erosion with soil building up at the stone wall here. Now we're outside of the cemetery. So this profile moves this direction, overlapping some of those crop marks too. Again, I just want to, there's lots of roots everywhere, so difficult to make these judgments, but there's 1 probable, 1 possible. This one, there wasn't a lot that was there, but there was a depression with a crop mark and a faint signature. So that depression tells me that the coffin is likely decomposed. That's why I can't see it. But the fact that there was vegetation, a depression, and a faint signature, again, suggests to me that it's a pretty clear indicator of a grave. Relatively shallow. As I said, a lot of roots are also in this profile. And then we've got another profile outside of the cemetery.
Why did you look outside the cemetery in those areas?
I looked outside. I always look outside of the cemetery everywhere. Everywhere that I do a GPR survey of cemeteries, because the walls of cemeteries are often not coincident with the burying ground extent. Walls are often built after the cemetery has been in use for some time. They don't usually come at the beginning. But also, not everybody is buried inside of a marked cemetery either, right? So I look outside because I think it's almost always possible that there are graves outside of the modern or known boundaries of a cemetery today, but also because it was flat here and I could do it. I couldn't do it with sloping here, here, or there, or I would have surveyed on those sides of it too. Yeah?
So when you find these graves that are outside of the walls, I mean, I don't mean you personally, but then are they marked or designated then that this is a burial site?
Sure, so that's something that I think varies from organization to organization that we do the surveys for, but in general, yes. That's what happens after we do this survey. The organization that's in control of the cemetery does some sort of plaque or marking, or they erect small markers at these locations too. It varies from cemetery to cemetery how they do it. Sometimes there'll be a marker that's erected at the cemetery that just sort of describes that this is an area where we know through these methods that there are this many known or marked graves, but there are this many other unmarked graves. Sometimes there's good historical evidence of who those individuals may be, but it's often very difficult and challenging to figure out who they are. You might have a record of people that are buried there at the town hall who you don't have them indicated on a headstone, but you can't then associate that person with, say, this grave here, or it could be this one, or this, it's very difficult to do that unless you know that that individual was married or the daughter or son of somebody. You could maybe leap to the conclusion that that's their burial next to them. So that's what I would say, is that it varies from cemetery to cemetery, but often the impetus of this work is to do just what you're saying, is to commemorate individuals in that way. So we're still in grid 2, outside of the cemetery, 2 more probable unmarked graves. They continue to be relatively shallow. And then finally, I'll show you one last profile here of a very high amplitude reflector, just outside of the wall, and again, very shallow. So, putting it all together, the geophysical evidence was overlaid with the markers, the depressions and the crop marks. 3 of the 10 depressions and 2 of the 3 crop marks were associated with geophysical signatures for graves. That's pretty good. Sometimes we have a higher overlap with the depressions, but again, if there's a depression, it generally means that the coffin is decomposing a lot to create that slumping. So there's not going to be a lot of geophysical signature that you see. But 6 of the 10 depressions were associated with a marker stone. So again, I feel pretty good about those depressions being indicators of graves because they are associated with those field stones. We identified 31 markers of various types, although some of those are overcounting, right, because there's footstones that go with a headstone. 18 of the markers were correlated with geophysical evidence. There were 13 probable marked burials, 17 probable unmarked burials, so that's 30 that I'm really sure about. 1 possible marked and 1 possible unmarked burial, but then 5 grave slumps and crop marks without geophysical evidence, but I still feel pretty confident about those as well. Giving us 41 total burials. You'll note that that number is higher than the 1973 and the 1989 surveys, but substantially lower than the 2007 survey. And I again think that that is largely due to the root system that we were encountering and measuring. But it also could be that 15 to 17 years have gone by since that survey, and it could be that the geophysical evidence of the graves in that time is significantly lessened due to erosion, due to soil conditions that have occurred. So it's higher than the earlier estimates, higher than some of the deed research would suggest, but still lower than that 2007 survey. 7, however, were identified outside of the cemetery walls, indicating, as we just discussed, that the cemetery walls probably are not coincident with the earliest use of this as a burying ground, or that there were other reasons why people might have been buried outside of the existing walls. Nearly all of the burials are very shallow. Again, I think that's not that they were shallowly buried necessarily in the 19th century, it's just that there's been a lot of soil erosion at this site.
Isn't there a lot of bedrock in that area?
Yeah, there is, but
That would precipitate a shallow burial, wouldn't
it
it?
would, but I don't really see the bedrock until we get to about 1.5 meters. So it would make it shallow, I agree completely. But I don't see evidence for bedrock being at like 50 centimeters or 70 centimeters. I see it a bit deeper. So for sure, it's a concern. I think there's been erosion, but I also think there's a lot of rocks, and I think it's hard to dig down. I think you're right too. I think it's part of it for sure. Yeah.
Can you tell the length of the coffins?
Sorry.
Can you tell the length of the coffins from your study?
You can, yeah. Some of them are smaller, like these two here. They look like they're smaller. This one here was a little bit smaller. This one is a little bit smaller. So we tried this one as well. But it's challenging because I don't know if it's decomposing, what parts of it are decomposing to. So, yeah. So, also, I think there's good evidence for 4 sort of orderly rows of burials within the cemetery walls itself, and then sort of 2 rows outside of it. And that's sort of the evidence that we were able to marshal with the GPR survey, which again is built on a lot of historical research that came before us too. So I'll answer any other questions you all have. Yeah, sure.
All right, well, you're looking at that picture, there are graves outside the walls.
Yeah.
Now, it seems like every ancient burial ground has a rumor attached to it that there were Native Americans buried there somewhere. And they would be outside of the boundaries of the sanctified ground. So as an archaeologist, what do you think of those rumors that seem to be attached to many of the ancient burial grounds?
Yeah, I would say that each cemetery is different, and that cemeteries that, some cemeteries actively prohibited the burial of people from different backgrounds within them. That doesn't seem to be the case of the Wheeler Baldwin Cemetery, which is clearly an integrated community in the 19th century where there are racially diverse people who are buried within the bounds of the cemetery. That doesn't mean that that extended to people who identified as Indigenous or Native Americans at that time. And
In
there
their
are,
culture, would they even have wanted to be buried in a cemetery with?
it's hard to say. Those are all individual decisions that somebody would make, but generally, I would say that Indigenous people in New England are often buried within cemeteries. It depends on the cemetery, it depends on the community. I think there's no reason to expect that the individuals who are buried outside of this cemetery were buried outside of it for those reasons because of the specific history of this cemetery. There could be other reasons though. There are some people who could have been pariahs of the community, not because of that, of their race or identity, but for other reasons. Or it could be that the cemetery was broader at one point and then became smaller too. It could also be that there are other, GPR, I don't mean to suggest that the research that we've done is infallible, right? So it could be that I'm misidentifying some of these too. So that's always a possibility, and certainly could be possible. There was other questions, yeah. Sure.
I'm Karen Leo, maybe you've already covered this, but I'm just curious about when you did this and how long it took and how big your crew was.
Sure.
Some people and.
So I didn't say any of that, so thanks for the question. I did it, I think in November, I don't remember. It was in 2024. I was there for 2 days. Yeah, so just me. Well, there were other people from the cemetery committee who helped clear the leaves and things, but I was the only archaeologist who was there. Yeah.
Because this is an interesting
I would say that there are there's historical evidence for integrated communities throughout New England. The burial grounds associated with those are not always as well known, but certainly people would have been burying their dead in areas. I mean, there are a number of communities that are like the Den community, spread throughout New England, but they are more rare than they are common, I would say.
The other thing about the history of this, how this spot became a cemetery, is that somebody's property and they made it then, or?
Yeah, so I mean, I think that other people in this audience probably know more about it than I do, but my understanding is that it's an area that when people start living in an area, there are, you generally, when you put down roots, you start burying, especially in the 19th century or the 18th century, you start burying members of your family close by. And so this is a community that grows up in this area where people are doing basket making, there's some milling and industries that are happening associated with the Ascatuck River, but it's also agrarian. And so it's not a village, but a small community, and people are living there, and so they start burying their dead there too. I mean, that's, I think, if you spend a lot of time in the woods of New England, you'll find a lot of these communities that spring up around the industrial resources that people are harnessing in the 19th century, and you'll often find burying grounds associated with them if the communities get large enough. If they're small, if it's one house or two houses, then you might bury your loved ones at the local town cemetery. But as the community gets larger, that's when you start to see cemeteries and churches and schools, as there was at the Den area.
Who owns this property?
Aquarium owns it today.
Aquarium owns it?
Any other questions?
Is it a difficult place to get to the city?
It's not so difficult, no.
Where is it located?
So I've been asked by Aquarian to not necessarily reveal that information. Because they're afraid of people going, I'm not suggesting anybody in this audience would do anything to the cemetery, but as the property owners, they're trying to be really good stewards of it and protect it. And so they don't want that necessarily publicized.
All right, I'll talk to you later.
So who paid for this? I'm curious about how.
The Connecticut State Historic Preservation Office provides a granting program that's non-matching. So historical societies or towns, such as the town of Easton, can apply for that money and have the survey conducted.
So this Easton Historical Society brought you in?
As it's grant-funded research from the state, yeah.
No, it actually
It was
came.
that cemetery.
So,
Sorry.
yeah.
Sorry, not to be territorial though. No, the cemetery committee, our job, because we report to the BOS, Board of Selectmen.
You're the cemetery?
Yeah, we're part of
There
that.
are two of them.
There are, well, three, there's a,
then you're-
we're spread around.
Yeah.
So, our job is to preserve and maintain cemeteries. This is technically not one of our domain, but it is in the town of Easton, and so we try to support Aquarian in a very ginger partnership, because this is their private property. That's the other reason why you can't go in there. No one's allowed on the water company property. It's illegal, it's trespassing, right? It's just private, it's water company, no one will go in. And for destructive reasons. So our job is to look for grants. Elizabeth, where's Elizabeth? She's the master, mind of looking for funds. Now, Adam Dunsby, all credit to Adam Dunsby, our prior first selectman, I think he was the first person that found this grant in the state. And he, as a first selectman, on behalf of the city, they got together. I wish Gary was here because he was the chair before me. But fill out the forms, and the BOS votes, and they did again this year unanimously vote to submit it to SHPO, to submit it to the state. And then the state approves it, and it's for 2 years, for a certain amount. And we got it just renewed for $8,000 for the cemetery grant. Now, this particular thing is, Elizabeth, you filled out the paperwork, didn't you?
Right, so
And
this
when
is,
was that?
that was in January 2024.
Right. So once again, Elizabeth, because she's the master builder of all grants, filled out
Don't keep saying that. I'm sorry.
We're gonna load your shoulders right up, sweetheart.
I give you credit, right? And then we went to the Board of Selectmen, they filled out, Tina and Chris Calvert, everybody in town hall, this is really the town grant, not that we represent the town. And then they vote and they bless it, and then they send it off to the state. So anything that comes back has to go to the Board of Selectmen, so that's technically how we do things.
So is that, so the cemetery, Union Cemetery, is that separate?
That's those folks back there. And that's private, when we talk about the difference.
So because it's a private cemetery, it's not part of the
Right, so the way the
cemetery.
cemetery committee was established by law through the state, what they call abandoned cemeteries, but they're actually neglected. As Bill Kaminsky would say, no cemetery is abandoned, they just don't have any owners anymore. So, in town, Gilbertown, Center, Lyon, and Den have no associations associated with them, whereas Union does. And so the town took them over, about 20 years ago now.
Yes, probably 20 years. Well, yeah, because
And it became our responsibility to maintain those cemeteries.
The town's responsibility to maintain.
because they're neglected,
And
there's,
why didn't Union come in at that time?
because
It's
Union's still open for
private.
business.
It's still open for business.
Because Barry, we still have people that are going to be buried there.
Oh, I see.
And if I'm not, correct me if I'm wrong,
No, you're
but I
right.
think to be called abandoned or non-owned, you can't have a burial for 40 years.
Right. I
40
left that part out, 40 years, that's
Yeah,
right.
have to have that.
So, but ironically, not ironically, but Jonathan Phantom, the Phantom family still has a plot in Center. And Jonathan, who is still alive, thank God, has a space there for himself. And his father was buried not too long ago, a couple of years ago.
Sort of grandfather.
So their grandfather did because they have existing, but you're right, that's, quote unquote, abandoned has to be, they have not have been a burial within the last 40 years.
Now, did anybody else ever hear, I don't remember where, but someone said that whoever was up there at Den, that there were a lot of black people who were working for him, and he was in the oystering business, and he would take these people out down to Bridgeport and take them out for oysters?
I've never heard that.
Have you
Have
ever
you ever heard that?
story?
I've never heard that. I know that Sylvanus was a basket weaver, I believe his brother was as well. A lot of the people that work, lived along Den Road, worked down in the foundry area in Valley Forge, which is now the Saugatuck Reservoir. Up there, a couple of the people were also colliers. They would construct these massive domes of wood covered with earth, and then they would set these little fires inside of them, and the smoke would burn, the fire would burn the wood into charcoal, and that charcoal would be used for the foundries and down there. There was a sheep farmer up there. They were all farmers at one time or another, but yeah. I hadn't heard anything about the oyster farm.
Okay, I remember.
That it's a trip.
That
They
might
go all the way
Well,
down
that's it,
there.
yeah.
It might be a good opportunity if we have questions. We do have refreshments. David, I don't know if you have anything else to say or share. We can all just enjoy some conversation and additional questions if you like. Please join yourself.